is Mr. Sanjeev Kumar Mishra. Please come on the stage.
Good evening, myself Sanjeev Mishra from JSW Energy Limited. Thank you RC for giving the platform for knowledge sharing. I am going to discuss about digital disruption in power industry. These are the topics I am going to cover: JSW Group overview, JSW Energy overview, concerns, challenges, and digital initiative what JSW Energy has taken up, and future course of action. JSW Group is a total $26 billion group in different platforms like steel, energy, paint, cement, and infrastructure. In JSW Energy, total generation capacity is around 6,500 megawatts, out of which around 50% is from thermal and 50% in distributed in different sectors like renewable, hydro, wind, and solar. As you know, now, presently thermal industry is facing a lot of challenges because of the capacity, installed capacity is around 400 gigawatt, and we are generating around, consumption is around 200 gigawatt. So there is huge gap, and you know very well there is a renewable power inception in the grid, and that is a cheap power than thermal power. So how to tackle that? JSW Energy, we are going for zero carbon footprint, but the power which we are generating now, how to utilize that using digital initiatives so that you can compete in the market and we can sell that power in the grid. As I told you, now because of the cheap power, we don't have PPA also, and the renewable power cost is cheaper than thermal power. To tackle with the cost, what we have to do, we have to increase the efficiency, we have to increase the availability, because when there is a real-time market huge demand, that time we have to sell the power. If our power plant is not ready, we cannot sell the power. And the operating cost has to be minimized. Then only we can sell the power, and we have to increase the reliability and as well as sustainability. In the leadership of Mr. Mishra, he is our head of the plant, we have taken different initiatives to reduce three major things which contribute the cost, generation cost: APC, heat rate, and oil consumption. As you know, if you don't monitor, we cannot, if you don't measure, you cannot monitor. So, what is happening now, in our power plant, we have DCS, and all the parameters are being monitored in DCS for control purpose and production purpose. We cannot measure it. Measure means we cannot compare it. So what we have done, we have tied up with OSFI. We have connected we have given some tags which are accountable for efficiency improvement, and all the data we have taken to OSFI, and there we have make one dashboard. If you can see, all the equipment in power plant, like all the CW pumps, cooling tower, mills, ESPT, all the equipment parameters we are transferring to OSFI, and from there we are monitoring that why there is a difference between the, like if you monitor from yesterday, today what has happened, that power has increased, and can we monitor, can we run it at efficient manner? This is about heat rate. In heat rate means the kilocalorie required to generate 1 unit of power. For that, what we have to do? We have to increase the heat, means we have to utilize less coal and we have to generate more power. For that, what we have to do? We have to take some measures like MS temperature, feed water flow, and HP exhaust temperature, inlet flow pressure. That parameter we have design parameter, but normally what we have to do? We used to run it as per design. But we never see, normally as an operator, we never see that it's optimum or not. So for that, we are taking this parameter to our OSFI, and there we are monitoring it. And based on this report, we are comparing that at, like if today we are generating 300 megawatt, at 100 megawatt, if you are going to generate because of the demand, the 100 megawatt power, what is the optimum value for that particular parameter, and we are comparing. If there is difference, Then we are working on it that what has to be done to reduce that value so that we can decrease the power cost. This is a OSA pipe vision where we are taking all the parameters, and there also we are generating the alarm system so that if there is a deviation from yesterday or in this month it has gone to higher value, then we will check what has happened and what is deviation. This is a daily monitoring dashboard. Daily monitoring dashboard we have made so that the daily meeting we are doing in this dashboard, and we are monitoring that what has happened leading to this plant load factor, availability, heat rate, generation loss, APC and sales breakup. That how much power we have sold to the grid, how much we are not able to generate because of there is no demand. We have also tied up with Schneider for our ENMS system. This is the energy management system. We have connected all the generator parameters to ENMS, and there we are monitoring that how much we are supporting to the grid, how much we are consuming inside the plant because we have connected JSW steel load. So here we are monitoring that difference. We are also going towards operation advisory system. What is happening now? Every shift people are coming and they are operating the plant, but we don't have the parameter that what is the optimum parameter. So what we are planning to do based on the AIML algorithm, the operator has to know that he is not generating the power at optimum rate. Like if we are generating the power at 100 megawatt and the unit the rated capacity is 300 megawatt, and we are running at we can run one zero loop pump, but we are running two pumps. So unnecessarily there is cost impact. Though it will generate the alarm to operator that you are not generating the power at the optimum rate, and you have to do this. And it will give the instructions, like here you can see, it will give the alarm that you are not generating the power at the optimum rate, you should go for these changes. One thing also we are already working on it, that what is happening whenever there is a problem, this is about electrical system, we have taken the ETAP software, that is the electrical transient analysis program, where what we are doing that if there is a problem in the site, it will trip our upstream breaker and that may lead to our unit trip. So the relay has to be coordinated. What is happening when we install the unit, we get it coordinated with the TC or ABB, whatever vendor has installed. But after that, what is happening? We are keep on adding the loads, but we never coordinate it. What is happening based on that? In the future, if there is a wrong setting, it can lead to our unit trip. So we are in this ETAP software, we are putting all the data to ETAP, and there we are checking the breaker coordination. If there is a gap, the minimum gap has to be 200 milliseconds between one breaker to two breaker. That gap is being maintained or not, because that will cost to our unit tripping, and that may cost to around 200 crore, 100 crore more than that. This is a single line diagram which we make in ETAP software. This is simple because we have so many units. So all the data we are fetching in here, and we are checking for coordination. And we also found there was a problem, and we rectify it by this software. And we are also looking for robotic advancement, that because of tube leakage, whenever there is a market demand, we are going to sell the power, and in that time only get the tube leakage. We are not able to sell in that time period, so we are losing huge money. So we are looking for, till now is under progress, we are looking for boiler inspection with robotic advancement, because now we are going manually, we are checking that tube thickness is proper or not. So that involves huge cost, and we cannot go to all the area in the boiler inside. So we are working on it for future work. And JSW also working on pumped storage. We are also planning to make one pumped storage plant in Vijayanagar and other locations. Wind energy 1.26 gigawatt power plant is already under construction, and hydroelectric in Himachal Pradesh 240 megawatt is already in construction. This is 2030 forecast.